Welcome to the next session on assignment problem, and today again we are going to see the special case of assignment problems. The example which I'll be taking today is of a unbalanced maximization assignment problem. Okay, the problem given to us to solve, or the example which we will be using, is we have to solve the following problem for maximizing the production output. The data refers to the production of an article for the given operators and machines. So we have the machines A, B, C and D, and the operators 1 to 5, and this is your output maximization problem. Fine, this is your payoffs. Now, if you look at this problem, first of all, it is an unbalanced problem. So immediately we are going to add a dummy column to make it balanced. Okay, and I'll rewrite this whole problem, and we have the new matrix, which is like this. So we have added a dummy column and the payoffs are zeros. Now, as this is a maximization problem, we can use a Hungarian method, which is basically meant for minimization problem, to solve this problem as well, by adding a simple step at the beginning of the problem. What is that? We are going to convert this profit matrix into a loss matrix first, and then go ahead and solve the problem using our regular steps of Hungarian method. Now, how do I convert this profit matrix into a relative loss matrix? I need to find the maximum number, or the largest element in this matrix, okay, which is in this case 11, and subtract all the other elements from this, which will give me a relative loss matrix. So let us convert this into a loss matrix first. How do I do that? 11 is the maximum number, so I'll use 11 and subtract each of the elements. Let us rewrite this: A, B, C, D and a dummy. I have here 1, 2, 3, 4 and 5. Okay, so 11 minus 10 will give me here 1. Okay, 11 minus 5 is going to give me a 6, then a 4, 3, and 11 minus 0 will give me 11 here. This will be 0, 7, 2, 1 and 11 again. Then 11 minus 8 will give me 3, then 7, then 2 again, followed by 4 and 11. Then 11 minus 7 will give me 4, then it will give me 11 minus 5, 6, this will give me 5, 7, 11 minus 0, 11. The last one, 11 minus 8 is going to give me 3, 11 minus 9, 2, this will give me 4, 6 and 11 again. Okay, so this is my loss matrix which I have converted my profit matrix into a loss matrix. Now comes my first step of row reduction or row subtraction. I'll find the minimum value in the row. The first row we have 1, and I'll subtract from 6, or from all the elements in this row. I'll subtract 1 from it. Let us write it: B, C, D, dummy, 1, 2, 3, 4 and 5. This is 4. 1 minus 1 gives me 0. This is 5, 3, 2 and 10. Then the next one, we have 0 here, so there is no change in this row. So this 0, 7, 2, 1 and 11 unchanged. The next one, we have 2 as the minimum. So let us do the subtraction. 3 minus 2 gives me 1, 5, 0, 2 and 9. The next one, minimum is 4. So we get here 4 minus 4, 0, 2, 1, 3, 7. And the last one, minimum is 2. 3 minus 2, 1, 0, 2, 4. Yeah, 4. And the last one, 2 minus, we get 9. Okay, cool. Let us now do the column reduction. The first column has a 0, so no change here, no change here, neither here. So only this column I have to do reduction, and this one. Okay, so I'll quickly write the row reduction or the column reduction. Step number 2. Or we'll write it subtraction. A, B, C, D, dummy, and let us write this 1, 2, 3, 4, 5. The column, the first column remain as it is because we have a 0 minimum value. Second one, again we have a 0 which is minimum, so no changes here. Neither in the third one. Now in the fourth one, if you look at this matrix here, in the fourth column we have 1 as the minimum value. So 2 minus 1 will give me 1. 1 minus 1 gives me 0. 2 minus 1, 1. This will be 2 and 3. In the dummy, we have 7 as the minimum value. So I'm going to use this and do the subtraction. So this will be 3, 4, 2, 0 and 2. Now we got the reduced matrix. Let us now go ahead and draw the vertical lines and the horizontal lines to cover the zeros, which I'll be doing it in this matrix itself to reduce my step. So the number of zeros, maximum number of zeros is 3 here, so I'll draw a line to cover this one. Then we have a single 0 here, a single 0 here, 1 here, 1 here. So we can directly cover this one, okay, and this one and this one. Fine. Now what are the number of rows which we have got? 1, which are covered, or lines which we have got, 1, 2, 3, 4 and 5. So you can see the number of lines is equal to the number of rows or columns. That means I have arrived at the optimum solution. Next step would be to do the assignment. So I'll quickly write all the values back again. Zero, zero, 1, 0, 1, 5, 7, 5, 2, 0, 3, 2, 0, 1 and 2, 1, 0, 1, 2, 3, 3, 4, 2, 0 and 2. We'll search for a single 0 in a row or column. So here definitely we have a single 0 here. So my first assignment comes here. And I have to cross the other zeros in this particular column. So I'll cross this out. The second assignment in this row, again we have this single 0 here. No zeros to cancel it here. Single 0 here. So we have got the first assignment. There is nothing to be cancelled again in this one, and finally this one. Okay, so we have come to the optimum solution, and the assignments are like this. We'll write the operators here. 1, 2, 3, 4 and 5. The machines which are assigned to them, the machines, 1 is assigned to A, 2 we have D, 3 goes to C, whereas operator number 4 is assigned to dummy, and the last one to B. Okay, and what is the production? For these machines, we can refer to the original matrix and get these values, which is actually 10, 10, 9. For dummy it will be 0 and 9 again for operator 5 and machine B. What is the total here? We have 20 and we have 18, 20, 38. And remember, this is your maximization problem. So I'm going to write maximum in my bracket here. Okay, and this has given me the final solution for my unbalanced maximization assignment problem. Okay, so I hope you have understood, and please remember, the most important step in this maximization problem is to convert your profit matrix, okay, which is this one, to a loss matrix. And how do I do that? I find the maximum number from my profit matrix and use this number and subtract all the other elements from this maximum element to arrive at the loss matrix. Got it? And the other steps are similar to the ones which we have done before. The row reduction or row subtraction followed by column subtraction, and then covering the zeros with horizontal and the vertical lines till we get equal number of lines, which is equal to n, the row or the column, and then finally the assignment. I hope you understood this. If not, please go through the video again and practice it out. Thank you.